Somewhere in occupied Europe, late 1944, a group of German artillery officers stood frozen around a piece of American hardware they'd just dragged off the battlefield. The M114 155mm howitzer sat before them, its olive-drab paint still intact, the white star barely scratched. They'd seen plenty of captured equipment before: Russian guns, British howitzers, French relics from 1940, standard procedure: test it, measure it, write a report, maybe scavenge some parts. But what happened next would shake everything they thought they knew about modern warfare. The gun crew they'd assembled, experienced Wehrmacht artillerists who'd served from the Polish campaign all the way to the blood-soaked Eastern Front, began loading and firing. 1 round, 2, 3, 4. The shells kept leaving the barrel in a rhythm that didn't match anything in German gunnery manuals. An officer stood there with a stopwatch, calculating the numbers, then rechecking them because they couldn't possibly be right. Then he looked up at his colleagues, his face pale, and someone finally said it out loud. They had never seen a howitzer sustain this rate of fire. Not in this caliber, not with this consistency, not without the crew collapsing from exhaustion or the breech mechanism starting to smoke and seize up. 4 rounds per minute, sometimes 5, sometimes 6. Their own prized SFH 18 howitzer, the pride of Krupp engineering, battle-tested across every front, could barely manage 2 rounds per minute with a veteran crew working in perfect synchronization. This wasn't just about having more guns. This was something fundamentally different. And in that moment, standing in the cold European air, those German officers realized they'd been fighting the artillery war with outdated principles while their enemy had rewritten the rules entirely. This is the story of how a captured American howitzer revealed a technological and doctrinal gap so profound that it would reshape artillery warfare for generations to come. You might think this is just another tale about Allied material superiority, more trucks, more tanks, more of everything, but this moment cut far deeper than simple logistics. Rate of fire in artillery isn't some luxury feature you add if you have extra resources. It's the razor-thin difference between suppressing an enemy battery before it suppresses you. It's the critical gap between putting steel on target during that narrow window, when your infantry desperately needs it, and arriving 30 seconds too late when your soldiers are already dead. German artillery doctrine in 1944 remained firmly rooted in World War I principles: methodical registration, careful observation, precision over speed. It was scientific. It was professional. It was also becoming catastrophically obsolete. Their standard heavy field howitzer, the 15 cm Schwer Feldhaubitze 18, SFH 18 for short, was a proven, reliable weapon. Krupp-engineered precision, respected across every front from the frozen steppes of Russia to the deserts of North Africa. But it fired roughly 2 rounds per minute under optimal conditions, and that assumed a veteran crew working in perfect synchronization with adequate ammunition supply and no incoming fire disrupting their rhythm. The M114 sitting in front of these officers was clocking 4 rounds per minute, sometimes 5, sometimes 6. And here's what made the German test team go absolutely silent. The American gun didn't seem to care whether the crew was made up of battle-hardened veterans or fresh recruits straight out of training. The speed wasn't about superhuman skill or heroic effort. It was engineered into the weapon itself. The context matters desperately here. By late 1944, the Wehrmacht was fighting a multi-front war of attrition it couldn't possibly win. Every single shell counted. Every minute of fire superiority counted. And across every battlefield, from the hedgerows of Normandy to the collapsing Eastern Front, American and British gunners were systematically drowning German positions in shells faster than German counter-battery fire could even begin to respond. This test, conducted far from the chaos of the front lines in the sterile, measured environment of a proving ground, confirmed with cold precision what German forward observers had been desperately reporting for months. The Allies weren't just bringing overwhelming numbers of guns. They were bringing guns that fundamentally operated on a different clock, built around a completely alien philosophy of how artillery should function in modern mechanized warfare. The psychological impact on these officers would have been immediate and devastating. They'd spent years, some of them entire careers, perfecting a system, refining a doctrine, developing a sophisticated way of thinking about indirect fire support. German artillery training was the envy of the world in 1939. Their fire control methods were mathematically elegant. Their optical systems were unmatched. And here sat a mass-produced American weapon, built by a nation that barely had a standing army in 1939, casually outpacing the pride of Krupp engineering on the single metric that mattered most in modern combat: how many shells you could put downrange before the enemy killed you. Let's dig into what made this gap so catastrophic. The artillery differential between German and Allied guns wasn't immediately obvious if you just compared specification sheets sitting in some Ordnance Bureau office. Line up the numbers in 1943, and they looked reasonably competitive. The SFH-18 threw a 43.5 kilogram shell out to 13,325 meters. The American M114 lobbed a 43 kilogram projectile to roughly 14,600 meters. Range disparity existed but wasn't catastrophic. Shell weight was nearly identical. Both were towed weapons requiring a prime mover. Both used similar propellant charges and operated on the same basic principles of indirect fire. On those static comparison charts filed away in dusty offices, these were peer weapons facing each other across relatively even ground. But wars aren't fought on specification sheets compiled by engineers who've never heard an artillery shell scream overhead. They're fought in desperate 6-minute fire missions where the side that puts more steel downrange in less time controls the outcome and determines who lives and who dies. Wehrmacht artillery crews in 1944 were still trained under standards developed in the 1930s, carefully refined through the campaigns in Poland and France, then battle-tested during the early victorious years on the Eastern Front, when German fire control seemed invincible. The doctrine emphasized precision above all else. Every shot was meticulously planned. Fire missions followed a rigid, almost ritualistic sequence: observation, calculation, registration rounds, careful adjustment, then finally fire for effect. The SFH-18's crew drill reflected this philosophy at every level. The breech operator opened the block manually after each shot, a physical action requiring coordination and strength. The loader and assistant loader manhandled the heavy shell into the chamber, a process that demanded careful choreography to avoid injuries. The fuse setter adjusted each round individually, based on the target distance and desired burst pattern. The gun commander verified every single element before calling for fire, because mistakes in German doctrine were considered unacceptable failures of professionalism. Under ideal conditions, rested crew, no incoming fire, proper ammunition supply, favorable weather, solid ground beneath the trails, a good German battery could manage 2, maybe 3 rounds per minute per gun. These were trained professionals executing a refined system. But ideal conditions were increasingly rare by 1944. Veteran crews had been bled white across 3 years of Eastern Front fighting. Their replacements were undertrained, sometimes former Luftwaffe ground crew or overage reservists who'd never served in artillery. Ammunition shortages meant rationing. Allied air harassment was constant, and the real-world rates often dropped well below 2 rounds per minute, as exhaustion, fear, and chaos took their inevitable toll. American artillery training had taken a completely different evolutionary path. The U.S. Army Artillery School at Fort Sill, Oklahoma, had been refining its methods since the 1920s, building on lessons from World War I, but taking those lessons in a radically different direction than the Germans. But the massive expansion after Pearl Harbor forced brutal standardization around 2 principles: speed and volume of fire. American officers were taught that massed fires, multiple batteries, sometimes entire battalions hitting the same target simultaneously, could shatter enemy formations before they ever had a chance to maneuver or take cover. That doctrine required guns that could pump out shells fast enough to maintain continuous suppression, to keep enemy heads down, to break unit cohesion through sheer overwhelming violence. The M114, which entered service in 1942 as America's industrial base shifted into total war production, was designed around this requirement from the ground up. Its semi-automatic breech block opened automatically after firing, cutting precious seconds from every reload cycle. The recoil system used hydraulic buffers that absorbed firing energy far more efficiently than spring mechanisms, letting the gun return to battery position faster and more consistently. Shell and powder were loaded separately, but the entire loading sequence was streamlined and simplified. Crew training at Fort Sill emphasized rhythm and repetition, drilling the movements until 4 rounds per minute became muscle memory, rather than heroic effort requiring perfect conditions. British gunners working with similar weapons, like the 5.5-inch gun howitzer, had reached comparable conclusions through their own brutal learning curve. The North Africa campaign taught them in blood that German accuracy meant absolutely nothing if you could silence their observers first with overwhelming volume. By 1943, British artillery doctrine explicitly prioritized rapid sustained fire over pinpoint accuracy in most tactical situations, accepting that some shells would miss if it meant the overall barrage could be delivered before the enemy reacted. Commonwealth crews regularly achieved 3 to 4 rounds per minute with their medium artillery, and the coordination between British and American methods created a combined Allied artillery system that operated on fundamentally different assumptions than anything the Wehrmacht could field. When those German test officers watched that captured M114 run through its paces, they weren't just seeing a faster gun. They were seeing the physical manifestation of a completely different philosophy about what artillery was supposed to accomplish on a modern battlefield. They were witnessing the end of their own doctrinal supremacy, rendered obsolete by a weapon that treated speed as more important than the meticulous precision they'd spent decades perfecting. The design differences between German and American howitzers reflected two nations that had learned opposite lessons from World War I's artillery-dominated slaughter. Germany emerged from that catastrophic war absolutely convinced that artillery had been too crude, too wasteful, too indiscriminate. The solution, in their view, was precision, better optics, better training, better fire control, more professional, more scientific, more Prussian. When Krupp engineers sat down in the late 1920s to design what would eventually become the SFH-18, they built a weapon optimized for accuracy above all other considerations. The gun carriage used a box trail design, a single rigid trail that kept the weapon rock-solid stable during firing, minimizing dispersion. But this design severely limited traverse. You couldn't quickly shift fire to a new target without physically moving the entire gun using the trails, a process requiring coordination between the crew and the prime mover. The recoil mechanism was reliable, but fundamentally conservative, using spring buffers that worked adequately, but took considerable time to return the barrel to battery position after each shot. The breech was a horizontally sliding wedge block, manually operated with a lever. It was robust, sealing the chamber perfectly. It was precise, rarely malfunctioning even under harsh conditions. It was also slow, requiring the breech operator to manually unlock, slide open, extract the spent case, then reverse the process after loading. Every single element of the SFH-18 assumed that well-trained crews would make the critical difference. The sighting system was excellent. German optics were genuinely world-class, superior to anything the Allies produced. But adjusting elevation and traverse required careful hand-wheel operation, precise cranking to get the gun exactly on target. The ammunition was superb, with quality control that ensured consistent performance and predictable trajectories. But each shell had to be individually handled, fuses manually set based on target distance and desired burst height. The gun could fire different charge combinations for different ranges, giving it tactical flexibility to engage targets at varying distances with optimal efficiency. But that flexibility came at the cost of complexity, requiring the crew to calculate and select the correct charge configuration for each mission, adding steps and potential points of failure to every firing sequence. Crew training emphasized doing everything correctly rather than doing everything quickly. Speed was desirable, certainly, but never at the expense of precision or safety. This approach worked brilliantly during the campaigns of 1939 through 1941, when German artillery supported rapid mechanized advances and rarely faced sustained counter-battery fire from disorganized retreating enemies. But by 1943, the operational environment had changed completely and catastrophically. Static fronts, attritional warfare, Allied air superiority that made daylight movement suicidal, and enemies who'd learned that the best counter to German precision was overwhelming volume delivered before the Germans could respond. The SFH-18's methodical design philosophy, once considered the epitome of professional artillery practice, had become a dangerous liability. American engineers approached the identical problem from a completely different angle. The M114 program began in 1939 when the U.S. Army, finally dragging itself out of interwar neglect, realized its existing 155mm guns were hopelessly obsolete. The result was a weapon built for industrial warfare rather than artisanal perfection. The carriage used a split trail design, two separate trails that spread apart during emplacement, giving the gun a massively wider traverse arc without any repositioning required. This single feature meant American crews could engage multiple targets in rapid succession, shifting fire across a 45-degree arc just by cranking the traverse wheel, while German crews were still physically manhandling their entire gun into a new position for target switches beyond 5 degrees. The M114's recoil system used hydraulic buffers with compressed air recuperators, a more sophisticated system than simple springs. When the gun fired, hydraulic fluid absorbed the recoil energy smoothly and progressively, while compressed air pushed the barrel back into battery position automatically and consistently. This system was faster, more reliable across temperature extremes, and required less maintenance under brutal field conditions, where precision mechanical components often failed. The breech mechanism on the M114 was the real revolutionary breakthrough that changed everything. It used an interrupted screw design with a semi-automatic feature that previous artillery had hinted at but never fully perfected. After firing, the breech opened automatically and ejected the spent cartridge case without any manual intervention. The loader could immediately insert the next round without waiting for breech operation, without coordinating with another crew member, without any wasted motion or time. This wasn't revolutionary technology pulled from science fiction. The French had experimented with similar systems in World War I, but American engineers refined it to the point of absolute reliability, then built it into a weapon that could be manufactured by the thousands using standardized industrial processes. Combined with simplified, streamlined crew drill, the semi-automatic breech cut reload time nearly in half compared to manual systems, and it did so without requiring superhuman skill or perfect conditions. The M114 also used a more efficient shell and propellant configuration that further accelerated the firing cycle. Separate loading ammunition, shell and bagged powder charge loaded separately, gave flexibility for different ranges and missions. But the bag charges were standardized, easy to handle even with gloved hands in winter, and designed to ignite consistently. Crew positions were optimized through actual testing, so each man's movement didn't interfere with the others. They could work in parallel rather than in carefully choreographed sequence. Everything about the weapon assumed that speed mattered more than perfection, that getting adequate fire on target quickly trumped getting perfect fire on target slowly, and that the enemy you suppressed first was the enemy who lost the artillery duel. The first M114 howitzers fell into German hands during the North Africa campaign, though initially in damaged or incomplete condition. Operation Torch, the Allied landings in Morocco and Algeria in November 1942, introduced American artillery doctrine to the Mediterranean theater for the first time. By early 1943, as U.S. forces pushed east through Tunisia to link up with Montgomery's British 8th Army, advancing from Libya, Rommel's Africa Corps found itself capturing abandoned equipment from battlefield losses and hasty retreats as the Axis position collapsed. Most of these early captures were too damaged for any meaningful evaluation. A direct hit from an 88mm anti-tank gun doesn't leave much intact to study except twisted metal. But by May 1943, when Axis resistance in Tunisia finally collapsed completely and over 250,000 German and Italian troops surrendered in one of the war's greatest defeats, Allied supply dumps fell largely intact into German hands. Among the captured material were functioning M114 howitzers, complete with ammunition stocks, technical manuals in English, and fire control equipment. The Heereswaffenamt, the German Army Weapons Agency, responsible for testing and evaluating all ordnance, had a well-established methodical system for processing captured weapons. Every major front sent back technical intelligence teams specifically tasked with recovering enemy equipment that showed interesting or superior characteristics. Anything worth studying went back to Germany by rail or ship, usually to proving grounds at Hillersleben near Magdeburg or Kummersdorf south of Berlin. These facilities had been testing artillery since the Imperial German Army days, with institutional knowledge stretching back to the Franco-Prussian War. By 1943, they'd evaluated Soviet 76mm divisional guns, British 25-pounders, captured French equipment from 1940, and various other Allied weapons. The process was systematic and thorough. Static inspection first documenting every component, then live fire tests under controlled conditions, then detailed engineering reports distributed to ordnance bureaus and field commanders who might face these weapons in combat. The M114 captured in Tunisia arrived at Hillersleben sometime in mid-1943, catalogued and prioritized for immediate testing given American expansion in the Mediterranean. Initial reports focused on the obvious features: split trail carriage, hydraulic recoil system, the semi-automatic breech that immediately stood out as different from German practice. German engineers recognized immediately that this was a modern, well-designed weapon incorporating several innovative features. But the real revelation came during live fire testing when theory met reality. The Sicily invasion in July 1943 and the subsequent Italian campaign provided additional opportunities for capture. The fighting at Salerno in September 1943 was particularly chaotic. German counterattacks nearly drove the US Fifth Army back into the sea in desperate fighting along the beaches. In the confusion of attack and counterattack, both sides lost and recaptured equipment multiple times as the front lines shifted across the same ground. At least 2 M114 howitzers were abandoned during the initial beachhead crisis, when American units pulled back under intense German pressure, then recovered by Wehrmacht forces before the Allies could destroy them during the eventual German withdrawal. These guns came with something even more valuable than the hardware itself. They came with American ammunition still loaded in their ready racks and technical manuals still packed in their storage boxes, not destroyed in the chaos of combat. The manuals were in English, naturally, but the Wehrmacht had extensive translation services and plenty of captured American personnel who could be interrogated about technical matters. More importantly, the manuals included detailed crew drill instructions, step-by-step maintenance procedures, and most critically the official US Army rate of fire standards printed in black and white: 4 rounds per minute, sustained 6 rounds per minute for short bursts during critical fire missions. German test crews initially assumed these numbers were propaganda, the kind of inflated claims every military makes in its official publications. Or they were theoretical maximums achieved under perfect laboratory conditions that bore no relationship to combat reality. No artillery piece actually achieved its published rate of fire under field conditions. Everyone in the artillery community knew that published numbers were aspirational targets, not operational reality. But when the Hillersleben test range assembled a crew of experienced artillerists and carefully walked them through the American drill procedures step by step, something shocking happened. The numbers held up. 4 rounds per minute wasn't propaganda or theory. It was reliably, consistently achievable with a properly trained crew following the American system. The semi-automatic breech worked exactly as designed. The hydraulic recoil system cycled predictably. The split trail traverse eliminated time-consuming repositioning. The weapon simply worked as advertised. The test reports from late 1943 and early 1944 documented this finding with typical German thoroughness and painful honesty. Engineers measured breech operation timing with stopwatches. They documented recoil cycle duration. They analyzed crew loading sequences, timing each movement. They compared the M114's performance against the SFH-18, firing under identical conditions with similarly experienced crews to eliminate variables. The conclusion was unavoidable and professionally devastating. The American weapon was sustaining twice the rate of fire of its German equivalent, and it was doing so because of fundamental design features that reduced crew workload and simplified operation, rather than demanding increased crew skill or superhuman effort. By 1944, Additional M114 howitzers had been captured on the Eastern Front, where Lend-Lease deliveries meant Soviet forces were also fielding American artillery alongside their own designs. The Germans recovered several more guns during their increasingly desperate fighting withdrawals through Ukraine and Belarus as the Red Army's massive offensives pulverized German defensive lines. Each captured weapon went through the same rigorous evaluation process at Hillersleben or Kummersdorf, and each one confirmed and reinforced the earlier findings. The German ordnance establishment now had a crystal-clear picture of what they were facing across every front. American artillery doctrine wasn't just about having more guns or more ammunition, though they had plenty of both. It was about having guns specifically designed and optimized to exploit rate-of-fire advantages in modern mobile warfare, where the side that suppressed the enemy first controlled the tempo of battle. The detailed test reports from Hillersleben paint a technical picture that goes far beyond simple round counts. German engineers, trained to document everything with obsessive precision, measured the M114's performance across multiple variables that revealed just how comprehensive American design advantages actually were. They timed the recoil cycle from the precise moment of firing until the barrel returned fully to battery position, 2.8 seconds on average. The SFH-18, by comparison, took 4.1 seconds for the same cycle under identical conditions. That extra 1.3 seconds might sound trivial when you say it out loud, but multiply it across a sustained 10-minute fire mission, and you're looking at the difference between putting 40 rounds downrange and only 25. In combat, where every shell could mean the difference between breaking an enemy attack and being overrun, those 15 extra shells mattered desperately. The semi-automatic breech operation saved another 1.5 seconds per shot compared to manual operation, time that accumulated relentlessly across sustained firing. Add in the split-trail traverse advantage, where the M114 could shift 15 degrees left or right without moving the carriage at all, while the SFH-18 needed full repositioning using the prime mover for anything beyond 5 degrees, and you start seeing why American batteries could engage multiple targets in rapid succession, while German batteries were still laboriously cranking hand wheels and coordinating with their towing vehicles. The sustained fire tests were particularly revealing because they reflected combat reality rather than theoretical maximums. German doctrine distinguished carefully between short bursts and sustained fire because barrel heat buildup and crew fatigue inevitably degraded performance over time. The test protocols at Hillersleben reflected this operational understanding. Fire as fast as possible for 5 minutes to simulate responding to an emergency call for fire, then maintain steady fire for 20 minutes to simulate supporting an assault, then measure how long the crew and weapon needed to return to full readiness for another mission. The M114 crews consistently hit 4 rounds per minute during sustained phases, occasionally spiking to 5 or even 6 rounds during the initial burst when adrenaline was high. More importantly, the weapon itself showed virtually no mechanical stress or degradation. The hydraulic recoil system maintained absolutely consistent performance across hundreds of test firings. The breech mechanism didn't require additional cleaning or cooling after rapid fire sequences the way spring-loaded systems often did. The gun could theoretically maintain this brutal pace indefinitely, as long as ammunition lasted, and the crew could physically keep up. The SFH-18 crews firing the same test profile peaked at 3 rounds per minute during initial bursts when the crew was fresh and motivated, but dropped to 2 rounds per minute during sustained fire. This wasn't because the German crews were inferior. These were veteran gunners selected specifically for their experience and skill. It was because the weapon itself demanded more physical effort and more time-consuming manual operations for each cycle. The manual breech operation couldn't be rushed without risking dangerous malfunctions. The spring recoil system needed time to fully cycle. The box trail limited rapid target switching. German engineers also evaluated ergonomic aspects, though they didn't use that modern terminology. They noted with professional frustration that the M114's crew positions minimized movement conflicts and physical interference. The loader and assistant loader worked on opposite sides of the breech, never getting in each other's way or competing for the same space. The powder handler stood clear of the entire loading sequence. The breech operator, in American crews this was often the same person as the loader, combining positions to reduce crew size, could perform his duties without complex coordination with other crew members or carefully choreographed timing. The SFH-18, by contrast, required much more choreographed teamwork where timing and coordination were critical. The breech operator had to manually close and lock the wedge block, then physically clear the danger area before the gun commander could safely call fire. The loader and assistant loader had to work in careful sequence rather than parallel, because the breech design only allowed access from one side. Every extra second of coordination multiplied across crew fatigue, stress, incoming fire, and the chaos of combat where perfect execution becomes impossible. The ammunition handling tests revealed yet another American advantage that compounded their rate of fire superiority. American bagged powder charges were significantly lighter and easier to maneuver than German brass cartridge cases, especially important when crews were exhausted or working in cramped positions under fire. The M114 used separate loading ammunition where the projectile went in first, then the powder bag second. This system allowed crews to adjust propellant charges for different ranges without switching entire ammunition types, tactical flexibility without sacrificing simplicity. German separate loading ammunition worked on similar principles, but American bag charges were specifically designed for speed and ease of handling. They stacked efficiently in ready racks. They ignited consistently across temperature extremes from Russian winters to North African heat. They produced less residue buildup in the chamber, meaning the gun could fire longer before maintenance became critical. The test reports noted with characteristic German attention to detail that after 100 rounds of sustained firing, the M114's breech required only basic field cleaning that any crew could perform in minutes, while the SFH-18 needed more intensive maintenance to remove powder residue and ensure safe operation. In combat, that difference translated directly to sustained fire capability. American guns could keep shooting through extended fire missions, supporting attacks, or breaking up enemy counterattacks. German guns needed more frequent maintenance pauses, breaking the rhythm of fire support, exactly when infantry needed it most desperately. These technical advantages weren't individually decisive. You could argue that 1.3 seconds of recoil time or 1.5 seconds of breech operation weren't dramatic differences. But warfare doesn't care about individual components measured in isolation. It cares about systems and how they perform under the worst possible conditions when everything else is going wrong. And as a complete system, the M114 was engineered to maintain high rates of fire regardless of conditions, while the SFH-18 required near-perfect conditions to approach its theoretical maximum performance. The tactical implications of this rate of fire gap became devastatingly clear when you examined how each side actually employed artillery in combat operations. American doctrine by 1943 revolved around the concept of time on target missions, known universally as TOT in artillery circles. The idea was operationally simple, but required sophisticated execution. Coordinate multiple batteries, sometimes entire battalions spread across kilometers of front, to fire at precisely calculated times, so that despite different distances to target all shells, arrived simultaneously in one overwhelming barrage. A properly executed TOT mission could drop 200 rounds on a single objective in 30 seconds. Imagine being on the receiving end of that. The shock effect was psychologically and physically overwhelming. German infantry who survived these strikes reported in after-action interrogations that TOT bombardments felt like the ground itself was exploding beneath them, like reality was tearing apart. There was no warning crescendo of approaching fire. No time to recognize the threat and dive for cover. One moment you're in your position, checking your weapon, maybe sharing a cigarette with the soldier next to you. The next moment, everything within 100 meters is erupting in a simultaneous cataclysm of steel and high explosive. The blast waves from multiple impacts happening at once create pressure effects that collapse lungs and rupture internal organs even in soldiers who aren't hit by shrapnel. The psychological impact matched and arguably exceeded the physical destruction. Soldiers who survived TOT strikes often became combat ineffective for hours or days afterward, unable to function because their nervous systems were simply overwhelmed. Unit cohesion shattered, communication broke down. Even veteran troops found it nearly impossible to maintain discipline when the world exploded without warning. But TOT missions only worked if your guns could fire rapidly enough to deliver the required volume before the tactical opportunity window closed. If your target was enemy troops massing for a counterattack, you had maybe 5 minutes from identification to when they moved out and dispersed. Slow-firing guns couldn't deliver enough shells in that window to achieve the necessary destruction and suppression. German artillery doctrine still operated on World War I principles of methodical barrage fire that had changed remarkably little since 1918. A typical German fire mission started with ranging shots. Forward observers identified a target, calculated coordinates based on map reading and geometry, and called for registration rounds. These were deliberate single shots, carefully adjusted until they bracketed the target. One short, one long, then splitting the difference. Only after successful registration did the fire for effect phase begin, and even then, German batteries fired in careful, methodical patterns designed to maximize accuracy and ammunition efficiency. This approach worked beautifully in the campaigns of 1939-1941, when German forces were advancing rapidly and enemy responses were disorganized. Precision fire could destroy specific targets, bunkers, bridges, headquarters, with minimal ammunition expenditure. It was professional, it was scientific. It minimized waste. It also gave enemy troops time to recognize they were being targeted and take appropriate countermeasures. By the time German shells were falling in effective concentration, experienced Allied infantry had already dispersed, gone to ground in prepared positions, or simply moved away from the registered impact area. The methodical approach that seemed professional and scientific in peacetime training had become predictable, telegraphed, and slow in combat against competent opponents. Counter-battery fire illustrated the gap most dramatically and devastatingly. When Allied forward observers spotted German gun positions, and with air superiority they spotted them quickly, they called for immediate suppression using radios and well-practiced procedures. American batteries could shift fire from their current mission, calculate new firing data, and start putting rounds downrange in under 3 minutes from the initial call. The first salvo might not be perfectly accurate, scattered across the target area, but it didn't need to be surgically precise. Volume compensated for any lack of pinpoint accuracy. By the time German crews realized they were under counter-battery fire and shells were already impacting around their positions, they had perhaps 30 seconds to make a life or death decision. The rapid American fire rate meant suppression was continuous, unrelenting. More shells were already in the air before the first salvo even landed. German crews had exactly 2 choices, both terrible: stay in position and take mounting casualties as the American gunners refined their aim, or displace immediately and cease all fire support for your own infantry, who were probably desperately calling for help. Either way, the German guns went silent at exactly the moment they were needed most. When the situation reversed and German observers spotted Allied batteries, the response sequence followed their doctrine: calculate firing data carefully, shift guns if needed, begin registration with ranging shots. But by the time German shells started landing in the vicinity of American positions, Allied batteries had often already displaced to alternate firing positions. The faster-firing guns could deliver their assigned mission and move to pre-surveyed backup positions before German counter-battery fire arrived. This created a cascading tactical advantage where American artillery could operate more aggressively, firing from positions closer to the front, because they knew they could shoot and scoot before retaliation arrived, while German artillery had to remain farther back and more dispersed, reducing their effectiveness. The Normandy campaign in June and July 1944 demonstrated this dynamic at operational scale with brutal clarity. American artillery battalions, firing in support of the breakout operations, Operation Cobra and the subsequent pursuit, regularly executed massed fire missions with 12 or more batteries participating simultaneously. German defenders, already reeling from Allied air superiority and armor breakthroughs, reported the artillery effect as continuous thunder that never paused. a rolling barrage that seemed to follow them everywhere they tried to establish defensive positions. Wehrmacht artillery tried desperately to respond, but they were fighting both rate of fire disadvantages and catastrophic ammunition shortages as Allied air interdiction destroyed supply trains and dumps. Even when German crews had shells available and could identify targets, they simply couldn't match the volume American guns were producing. For every German round fired, 4 or 5 or 10 American rounds came back. After-action reports from German commanders repeatedly mentioned being outshot by Allied artillery. Not outranged because the SFH-18 could reach most tactical targets, but simply buried under more shells than they could possibly answer. One German division commander in Normandy estimated his artillery was being outfired 4-1, and he noted grimly that was being generous. Some American fire missions delivered 10 times more shells in the same time period. The Eastern Front showed disturbingly similar patterns once Soviet artillery began adopting American techniques and receiving American equipment. The Red Army received hundreds of M114 howitzers through Lend-Lease, and Soviet artillery doctrine evolved rapidly to emphasize massed fires and overwhelming volume. Soviet forward observers began calling for the same kind of devastating TOT strikes that characterized American practice. German artillery on the Eastern Front, already struggling with ammunition shortages, crew casualties, and the sheer scale of the front, found themselves facing the same overwhelming volume of fire they'd experienced in Normandy. By late 1944, Wehrmacht artillery effectiveness had degraded catastrophically, not because German gunners suddenly forgot their training or lost their courage, but because their weapons and doctrine simply couldn't compete with enemies who'd fundamentally optimized for speed and volume over the precision that German military culture prized. The German response to this documented inferiority followed grimly predictable patterns: engineering studies, modification proposals, attempts to retrain existing crews, and ultimately, resigned acceptance that the gap couldn't be closed. The Heereswaffenamt commissioned several urgent projects in late 1943 and early 1944, aimed at somehow improving the SFH-18's rate of fire to match or at least approach American performance. One proposal, developed by engineers at Rheinmetall, involved retrofitting semi-automatic breech mechanisms to existing guns already deployed across multiple fronts. The engineering team developed a prototype modification that replaced the manual wedge block with an interrupted screw design closely copied from captured M114 examples. The prototype worked reasonably well in controlled testing at Hillersleben. Rate of fire increased to roughly 3 rounds per minute, not matching American performance, but representing significant improvement over baseline SFH-18 capability. But implementation faced absolutely insurmountable obstacles that doomed the project before it ever left the testing phase. Retrofitting thousands of guns already deployed from Normandy to the Vistula required pulling them off the line for factory work, skilled labor that no longer existed in adequate numbers, and materials that were desperately needed elsewhere. By 1944, Germany was struggling to produce enough basic ammunition and essential spare parts to keep existing weapons functioning. The idea of diverting resources to breech modifications for marginal improvements couldn't possibly compete against more critical needs like anti-tank gun production, aircraft manufacturing, and simply replacing combat losses. The program died quietly in committee, filed away as theoretically sound but operationally impossible. Another approach focused on crew training reforms, attempting to compensate through human adaptation for mechanical limitations. If German gunners couldn't get better weapons, perhaps they could learn to operate existing weapons faster through improved drills and intensive practice. The artillery school at Jüterbog issued new training directives in early 1944, emphasizing speed drills and rapid-fire techniques. Crews practiced loading sequences repeatedly, trying to shave precious seconds off each cycle through pure muscle memory and coordination. Some units reported modest improvements. Veteran crews who'd been firing 2 rounds per minute managed to sustain 2.5 rounds under ideal conditions with intensive practice. But training couldn't overcome fundamental mechanical limitations. The SFH-18's recoil system still needed 4.1 seconds to return to battery, regardless of crew skill. The manual breech still required physical operation that could not be accelerated beyond a certain point without risking dangerous malfunctions. The box trail still limited traverse. You can't train your way past physics and engineering constraints. The training reforms also arrived far too late to matter strategically. By mid-1944, German artillery units were being filled with hastily trained replacements, former Luftwaffe ground crew rendered jobless by destroyed airfields, overage reservists pulled from retirement, even impressed foreign nationals from occupied territories. Teaching these men basic gunnery procedures took absolute precedence over advanced speed drills. Many German batteries by late 1944 were operating with crews who'd never fired their weapon in training, learning on the job while under fire. Some German commanders attempted tactical adaptations to compensate for rate of fire disadvantages that their superiors couldn't solve through equipment or training. They experimented with concentrated battery deployments, putting more guns in smaller areas to achieve higher local shell density, even with slower individual gun rates. 8 guns firing 2 rounds per minute in the same grid square delivered 16 rounds per minute total. Crude mathematics attempting to overcome technical inferiority through massing. This approach sometimes worked in carefully prepared defensive situations where German artillery could pre-register targets and fire from camouflaged protected positions. Concentration could achieve temporary local superiority when German guns achieved tactical surprise. But concentration also made batteries catastrophically vulnerable to Allied airstrikes and counter-battery fire that were now guided by sophisticated radar and aerial observation. A single well-placed Allied fire mission could knock out multiple German guns clustered too tightly together. One American pilot spotting a concentration could call in devastating airstrikes that destroyed entire batteries in minutes. The tactical adaptation created as many problems as it solved, trading rate of fire equivalency for survivability. Other units tried rapid displacement tactics straight from the textbook. Fire a quick mission, then immediately move before counter-battery fire arrived. This worked better than concentration, especially with veteran crews who could emplace and displace efficiently. German artillery operating this way could preserve their guns and maintain some tactical effectiveness. But this approach still couldn't match the volume American batteries delivered. A German battery firing 10 rounds then displacing couldn't suppress targets as effectively as an American battery firing 30 or 40 rounds from the same position in the same time period before the Germans even finished their displacement. The mathematics remained brutally unfavorable. The German armaments industry did manage to field one new weapon that partially addressed the rate of fire problem, though it arrived far too late and in far too small numbers to matter. The 15cm Canon 18 in Meuse-la-Fête, essentially an SFH-18 barrel mounted on a newer, more modern carriage with significantly improved traverse and some streamlined features. Production began in late 1944 as German industry was being systematically destroyed by strategic bombing, but a few hundred were manufactured and deployed before final collapse. Even this improved model couldn't match Allied rates of fire because it still used fundamentally the same basic breech system and recoil mechanism as its predecessor. The new carriage helped substantially with rapid target switching and reduced emplacement time, genuine improvements. But it didn't solve the fundamental issue of cycle time. The weapon remained a methodical, precision-oriented gun in a war that had moved decisively toward volume and speed. Germany simply didn't have time, resources, or industrial capacity remaining to design and field a completely new howitzer optimized from the ground up for rapid fire the way the M114 had been. The V-weapon programs, V-1 flying bombs and V-2 rockets, were absorbing enormous resources, skilled labor, and high-priority materials that might otherwise have gone to conventional artillery development. But even without V-weapons consuming resources, the strategic situation by 1944 made major artillery development programs completely impractical. German industry was operating under relentless bombardment. Transportation networks were collapsing. Raw materials were increasingly unavailable. Skilled workers had been drafted into the Wehrmacht or killed in bombing raids. The industrial base that had produced the SFH-18 in the 1930s simply no longer existed in any functional form. By the final desperate months of the war in late 1944 and early 1945, German artillery had effectively conceded the rate of fire battle entirely. Ammunition shortages meant that theoretical fire rates became completely irrelevant academic exercises. Units were rationed to 10 or 20 rounds per gun per day, sometimes less. Forward observers stopped calling for fire missions because they knew the shells weren't available. At that point, whether your gun could fire 2 rounds per minute or 6 rounds per minute didn't matter at all because you didn't have shells to sustain either rate for more than a few minutes. The captured M114 test reports gathered dust in Heereswaffenamt files, academic exercises documenting problems Germany utterly lacked the capability to solve, even if they'd recognized them years earlier. The lessons from that captured M114 test didn't vanish into history with Germany's unconditional surrender in May 1945. If anything, Allied artillery performance in World War II became the foundational case study for post-war artillery doctrine worldwide, studied in every military academy and shaping equipment development for generations. NATO standardization agreements in the 1950s, as the Western alliance organized itself against the Soviet threat, explicitly adopted rapid sustained fire as an absolute core requirement for all member nation artillery. The benchmark rate for 150 mm howitzers became 4 rounds per minute sustained with burst capability of 6 to 8 rounds for critical fire missions. This wasn't an arbitrary number pulled from thin air. It was the M114 standard, validated by 4 years of combat across every theater from the Pacific Islands to the hedgerows of France, proven in blood against skilled opponents. Nations joining NATO had to meet this standard or face pressure to replace their artillery entirely. The message was absolutely clear. Precision without speed was obsolete. Volume of fire, the ability to deliver overwhelming shells rapidly and sustain that delivery, had become the defining characteristic of effective modern artillery. Any weapon that couldn't meet this standard was a liability, not an asset. West Germany's rearmament in the 1950s presented a particularly interesting and somewhat ironic case study. When the Bundeswehr formed in 1955 as West Germany rearmed to face the Soviet threat, it faced fundamental questions about what artillery doctrine to adopt for this new German army. Former Wehrmacht officers were deeply involved in planning and organization,